Okay, so we're continuing on with the fall 2018 unit test practice. So we're on the free response. And I took the liberty of including my little flow chart in here just to make life a little bit more manageable. It's a pretty good organizational strategy. I'm not going to say it's the best. I mean, it's what I'm looking for. So for the purposes of this course, it's probably the best. But, in real life, who really knows? A concerned group of citizens wants to show that a minority of voters support the president's handling of a recent crisis. Now, mind you, this is fall 2018. All right, so no current events involved here. If a random sample of 500 voters gives 228 in support, test the claim that a minority of voters actually support the president's handling of the crisis at the 0.05 level of significance. All right, so here's my 0.05 that goes in for alpha. Now, the minority of voters, a minority of voters. Minority is the opposite of majority, mathematically. So what it means is that the population proportion is less than 0.5. All right. So that's all we're asked to find here. Whether or not it's true that the population proportion is less than 0.5. All right. People have, based on, honestly, I was going to say personal bias, but I don't know if that's necessarily true. That's just anecdotal. Maybe, maybe not. They just see the word minority and they think it just that I'm talking about not white people. So what I'm talking about here is a percentage of people. All right. So minority is less than 0.5, majority greater than 0.5. Everything else, like if it's not a minority or a majority, it's just simply equal to 0.5. And that's what the null hypothesis is going to be. All right. So the calculator test here, well, they gave us an n value of 500, and they gave us an x value of 228. That's counts, or those are counts out of a total number of trials. All right. So this gives us a p hat, not that we really need to know that in order to conduct it on the calculator, but this is going to support a one prop z-test. All right, so one prop z. Now, I'm not going to lie. People in the past have said, okay, that sounds great. I'm just going to go through the different calculator options until I find the one that matches up with the information that I have. I'm like, by all means, go for it. Right? It might take you a little extra time, but it'll get the job done. So 0.5, 228, 500. It's a less than symbol because that's what our alternative hypothesis said. And then I calculate, and we're looking for the p-value 0.0245. All right, that p-value is going to be less than alpha. Poor quality alpha, let me do that again. All right, so if it's less than alpha, that means that there's sufficient evidence to reject the claim that the population proportion of people who support the president's handling of the crisis is 0.5. So I'm just going to jot that down. The population proportion of people who support president's handling of crisis is 0.5, and that happened at the 0.05 significance level. All right, let me bring up my writing tool here. Some would say I'm the writing tool. at the 0.05 significance level. Therefore, the claim of, so I'm going to get rid of that. I'm going to take a little liberties here. Claims of a minority of support. Because we already know like what it is in relation to is going to be true. All right, and that's because there was enough evidence to reject the null, which means the alternative is the one that we're calling true. And since the first sentence in our conclusion addresses the null, it should be the verbal representation of p equals 0.5, whereas the second sentence should be the verbal representation of p less than 0.5 being equal to true. All right. So that's what I'm looking for. I'll take it as a typo. My table needs to be much wider. I never have enough room to fit it in there. And even if you do, like if you had a handout for this, whether you do or don't, it's still, I need to be able to write in it too. So I'll take it as a typo. So number 17, high school students are preparing for the Regents exam. Well, no, they're not. A teacher offers a review class. Prior to and after the class, the teacher gives a diagnostic test. The results are in the table as follows. All right, so we have some data. Then data has to go into the calculator. So stat edit. Let me clear out my stuff. Clear enter. Clear enter. Clear enter. I'm going to put all this stuff in here. So 75. So before is going L1, after is going L2. Just take your time and make sure you don't botch this, because there isn't really much calculation outside of, you know, the built-in functions in the calculator. So you don't want to take the chance of losing full credit on a solution. Not to say that you'll lose all credit, but, you know, losing the opportunity of getting full credit for a, you know, simple typo. Typo. That's my middle name. Ted Typo Can. Oh, right on cue. I wish I could say I did that on purpose. 75 and 55. And again, like I always say, assuming I can speak clearly, check it in a way that's different from the way that you typed it in. If it's a take-home assessment or graded homework assignment, perhaps have somebody that you live with double check it for you, because sometimes a fresh set of eyes is all you need. All right, so then you go on to L3, hit enter, all right, and then type in L1 minus L2. All right, I like to bang that stuff out of the way immediately. We'll come back to that, but the calculator's set up so we're good there. We're going to use an alpha equals 0.01. And we want to know if the course is effective. All right, effective can mean so many things. Cause is an effect, but I think it would be kind of more than kind of misleading if a person were to say, yeah, my review course is really effective. It caused a change in scores of students before and after they took my course. And it turned out that the change was that they all did worse. You know, that's not really what we're looking for. So we're gonna assume that effective means that scores improved. All right, and that would be that the before values are less than the after values. All right, so we have the mean for the first set would be equal to the mean for the second set. That would be, I don't want to say it's ineffective. It's just not the kind of effective that we're looking for. All right. So the alternative would be that mu1 is less than mu2. All right. That would be showing improvement. Match pairs test, we use a t-test. So stat, test, t-test. Oh. Okay, so what I did there was I did stat, test, t-test, and it pasted it right into my display here. That may not happen for you, but if it does, don't clear, don't do anything, just quit. Stat, edit, and you'll see that it didn't change anything because I didn't hit enter. All right. If you're ever in doubt, if you're in some kind of weird menu, hit second mode. That'll bring you to the home screen. Then do your stat, test, t-test. All right. We have raw data in our calculators. The mu sub o for a match pairs test is always going to be equal to 0, or at least as far as we're concerned. And that's because if mu1 is equal to mu2, that's because mu1 minus mu2 is equal to 0. We call mu1 minus mu2, we call that mu sub d is equal to 0. That mu sub d, those are the values that are being stored into the graphing calculator in L3. All right, so the L3 values, in order to support the null hypothesis, shouldn't be too far away from 0. All right, and again, our data are stored in L3. The frequency values, you can just leave that at 1, and we want this to be a less than symbol. All right, calculate, and we get a 0.0755. All right, the alpha value is 0.01, so the p-value is greater than alpha. It's not less than alpha. That means that there's insufficient evidence to reject the claim that there is no difference in population mean score. Oh, let me thin that down. Thin down the mix. Before and after. Review at the 0.01 significance level. Therefore, the claim that the course is effective is going to be false. And again, that's because we didn't have enough evidence to say that the null was incorrect, so we're going with that, which means the alternative has to be the one that's incorrect. All right. So a lot of details there, but a lot of the heavy lifting is done behind the scenes in the calculator. Now, we didn't really go over how to do, get these numbers, the p-value, by hand. So I don't expect any kind of gratitude or anything like that. Because you don't really know just how complicated it is to do this stuff if you didn't have a calculator just spitting these numbers out at you. What I will say is that there's a reason why I'm putting so much emphasis on the conclusion. The conclusion has to, what we have here in this table has to be good because you don't have to do any of the work that's in the calculator. All right. And I'm sure there's some of us that would rather do the math. I don't want to do this writing stuff. I'd rather just crunch the numbers. Yeah. Sorry. Number 18. And you'll see there's a bonus problem on this page, but that's not going to be on this test, so just pretend it's not there. Okay, so assuming my pen wants to work. Students at a local high school randomly selected 140 student cars and found that they had ages with a mean of 400. Jeez. It's a Monday. That's the only thing I can come up with. They had a mean of 4.12 years and a standard deviation of 1.32 years. So these are the student cars. I'm just going to make a note of this. Student. I had an administrator a bunch of years back that would always say students. Like that's how she would enunciate it. And I always thought that was strange. Like you could just say it like super fast like the rest of us. X bar is equal to 4.12. S is equal to 1.32. And N is 140. Figured I'd put the N at the end. A faculty. The X bar, 5.22. So faculty cars are older. Standard deviation, 3.72. And there were 32 of those cars. 0.05 significance level. We want to test the claim that the student cars are newer than faculty cars. All right, these are the years, the ages of the cars in years. All right, so if the student cars are going to be newer, then the ages for the student cars would have to be less than the ages for the faculty cars. All right, so mu1 equal to mu2 for the null, always an equal sign. Mu1 minus mu2, minus, wrong notation, less than mu2 for the alternative. All right, and this is going to be a 2-sample t-test. And that is because we have 2 independent samples, students and faculty, not coming from the same population. And we're comparing them to one another. All right, so stat, test, 2-sample t-test is option 3. It's not option 3. I hit the wrong thing. Option 4. Very easy to do that, I think. All right. They did not give us raw data, so I'm going to stats. The reason I put the n value at the end is because that's how the calculator calls for it. It asks for information from your first group. So now sub these values. And then from your second group. You want to be consistent. So don't start mixing and matching your subscripts. So 4.12. 1.32, 140, 5.22, 3.72, and 32. We want a less than symbol, and we talked about this in the lesson video. We're always going to keep it no for pooled. So calculate, we're looking at 0.0543 is the p-value. All right, the p-value is equal to 0.05, so it's actually not too far off, but it is not quite enough or small enough to be where we need it to be. So the p-value is greater than the alpha. If the alpha value is 0.01, it would be a different story, but we're going to say that there's insufficient evidence to reject the claim that the population mean ages of student and faculty cars are equal at the 0.05 significance level. Therefore, the claim that student cars or newer is, already had the is, false. All right. And, it depends on the motivation for this particular study. You can go either way. Right? So somebody might have selected a 0.05 significance level, like we have here, and somebody might have selected a 0.10, which wouldn't have changed anything. And somebody might have selected a 0.01, which would have completely changed the conclusion for the study. All right, so a lot going on with this one, and I think it's a good example of how, depending on which side of the aisle you're on, you could draw different conclusions just based solely on